Hello, awesome Pre-Calc students, and welcome to our Week 2 lesson on trig ratios. Our Week 2 essential question is to stay tuned during the entire recording because at some point I will ask you to solve and put a specific answer into the Dropbox to earn your points for this week. So every single week, you guys can earn 10 points from these live sessions. So as long as you're paying attention and putting it in the Dropbox within 1 week of the original session, then you will get full credit. If it's up to 2 weeks late, you get 5 out of 10 points, and anything after 2 weeks, you are not allowed to submit it any longer because it's way past the due date at that point. So what is this unit? What are we learning about? Trigonometric ratios solve all kinds of triangle problems. So this semester, we're going to be able to solve for missing sides or missing angles. We're going to start with right triangles, but then we will move on to be able to solve any kind of triangle. We're going to use these problems to find elevation, height, also natural phenomenon, or cyclical behavior. So let's kind of go back to the basics of when we first learned about SOHCAHTOA, or our law of sines. And what we learned was, let me grab my pointer tool here. So sine A, if we're talking about sine is opposite over hypotenuse. So if I'm talking about sine A, I need to look from angle A. So let me highlight angle A. So my opposite side is the one directly across from it. So that would be my little a. And my hypotenuse is the longest side. So that would be side C. So in this particular triangle, my sine of my A angle equals little a divided by little c. If I'm looking from a different angle, this time let's check it out from angle B. My opposite would be little b, and my hypotenuse would be C. So how we answer our SOHCAHTOA questions always depends on what angle we are referencing. What angle are we referring to? Let's talk about cosine. So if I'm talking about cosine of angle A, cosine is AH. So that means, adjacent. I need my eraser. Adjacent over hypotenuse. Adjacent means like a next door neighbor. That's what adjacent means. So if I'm looking on my picture here, I have two sides that are touching A. I have B and C. So adjacent is always going to be the neighbor, but it can't be the hypotenuse because that has a special name. It's always going to be the longest side. So for adjacent, that makes my adjacent angle B over my hypotenuse, which is C. If I'm looking from angle B in my second example, my adjacent angle would be A, my hypotenuse would still be C. So we can always easily pick out the hypotenuse because it's always going to be our longest side. So when we first learned about these trig ratios, probably back in Algebra 2, a little bit in geometry, we learned this word called SOHCAHTOA that's going to help us remember our trig ratios. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So again, remember, it's really important that when we're looking at our triangles that we are talking about referencing which angle, which sides are going to help us. Once we know which sides, then we know which trig ratio to pick. So we're going to practice a few. That was just a little quick review for you. So here we go. We want to be able to write tangent as a ratio of sine and cosine. So let me just give you a minute. Can you write down what you know about tangent? So tangent is opposite over adjacent. What if I told you that we can also write tangent? Sorry, I really need a new stylus here. What if I also said we can write tangent as the same as sine over cosine? So why is that true? Can you guys please write out what sine is and what cosine is, and let's just see what we get here. So take a quick minute to do that. So we get that sine is opposite over hypotenuse and cosine is adjacent over hypotenuse. When we have a big old fraction bar here, do we remember how we can, instead of saying divided by the bottom, how else we can rewrite it? So here's my top. And my bottom, we can write it as multiplying by the reciprocal instead of doing the division. So my hypotenuses are going to cancel, and that leaves me with opposite over adjacent. Which, hey, that makes sense because take a peek. That's what tangent is, right? Tangent is sine over cosine. I'm sorry, tangent is opposite over adjacent, and that's what we just proved that you can get by rewriting tangent as sine over cosine. So you can write it, and this is going to be important. You're going to use this a couple times this semester. So we need to know that tangent is opposite over adjacent, but we also need to be able to recognize that tangent is also sine divided by cosine. They're the same thing. So now let's come into a real problem and let's talk about what if we don't know all of the sides. And we're going to work on this one. So it says if cosine theta, this is our sign for theta, if cosine theta equals 6 over 12, find sine theta and tangent theta. So first of all, they want us to do sine of theta. So we're talking about from this angle of my triangle. And it tells me, sorry, I guess we're starting with tangent or cosine. This pen is really tripping me up today. Sorry about that. So our cosine is 6 over 12. So let's remind ourselves what cosine is. It's adjacent over hypotenuse. So I know that those two sides are 6 and 12. How can I now rewrite it as sine theta and tangent theta? Well, the first thing I have to do is I have a missing variable over here. I have a missing side. If we know right now we're dealing with all 90-degree triangles, there's a way that I have that I can solve for my missing side, and that's using Pythagorean theorem. So your a squared plus my b squared equals my c squared. So 36 by the time I get x squared by itself, I get x squared equals 64. So x would be 8. So my missing side is 8. Now that I found my missing side, now I can go in and ask myself, what is sine of theta? So sine of theta would be opposite. So we're still looking from the same angle here. Opposite would be 8 over hypotenuse. And my tangent theta would be my opposite, which is 8 over adjacent, which is 6. So we were able to take one trig function, relabel my triangle. Using Pythagorean theorem, we found our missing side, and from there we were able to now rewrite my fractions as sine and tangent, my two other trig functions. Remember, at any time, if you guys have a question, go ahead and press pause. So this one's the elevation of a mountain. It says a surveyor measures the angle of elevation to a point on a mountain that is 6 miles away to be 10 degrees. The vertical change in elevation from the point where the surveyor is standing to the point on the mountain is blank miles. So let's again draw a picture. That way we have a visual representation of what's going on here. So here's kind of my mountain, but it wanted us just to pick a point, to a specific point on the mountain. So this again is going to be a 90 degree. It says that the surveyor measures the angle of elevation as 10 degrees, and it's 6 miles away. So the one that I don't know says, what's the change in elevation? Change in elevation is the same as height. Let's go ahead and set up my problem. So I need to use the trig function that involves the opposite and the adjacent. So opposite and the adjacent. So again, in this case, it would be tangent. So tangent 10 equals x divided by 6. Multiply both sides by 6 to get your x by itself, and we'll get 6 tangent 10 equals x. Type that into your calculator. Again, make sure you're in degree mode, not radian mode. And we get 1.06 miles because it wanted it to the nearest hundredth of a mile. So tenths place, hundredths place. So there's a couple common values that you guys are going to find while we are working with these types of problems. You don't need to memorize these right now. As we work through Unit 1, I will be teaching you how we find each and every one of these values. But basically, it's by setting up triangles. So like the first triangle down here, this would be when it's a 30 degree. The green one is when it's a 60 degree. 45 degrees. And the red one that covers the whole way would be 60 degrees. So these are just some common values that we are going to get over and over and over and over again. So you're going to see them periodically as we are working through this unit. Talk quickly about inverses. So an inverse. We've learned about sine, cosine, and tangent many, many times. So now we're going to introduce 3 new ones. We have cosecant, secant, and cotangent. Basically, the inverses is just going to be, it just means 1 divided by one of our old trig ratios. So cosecant is the same as sine to the negative 1 or 1 over sine theta. Because remember, that's what a negative exponent means, right? It means you move it to the denominator, or you move it to the opposite side of your fraction, and it becomes a positive. So just to remind you, like if I had x to the negative 2, that's the same as 1 divided by x squared, right? I just had to move it to the denominator, and it became a positive. So cosecant, when we see that, it's the same as sine to the negative 1, which is really 1 over sine theta. If I see secant, that's the same as cosine to the negative 1, which is 1 over cosine. And if I see cotangent, that's the same as tangent to the negative 1, which is 1 over tangent. So let's put these into practice, and here's where your question for the day is going to come into play. So it says if tan theta equals 5 over 12, find the values of all other trig ratios for theta. So let's start by first labeling my sides of my triangle. So here's my tangent for theta, and it says it's 5 over 12. So tangent is opposite, so my opposite side would be 5, and my adjacent side would be 12. So the first thing that we have to do in this problem, before I can fill in sine, cosine, tangent, cosecant, secant, cotangent, we would need to find my missing variable right here. But for now, let's fill in the ones that we know how to do. So tangent, which is right here, opposite over adjacent, so that would be 5 over 12. So cotangent would be the opposite, right? It would be the inverse. So the inverse of tangent would just be 12 over 5. So if you notice, Tangent's opposite over adjacent. So cotangent just flips them upside down. It's adjacent over opposite. Isn't that super cool? Super cool, super easy. Okay, so for your essential question for the day, first you need to find what x is. And then I'd like you to type in 2 answers into the drop box for week 2. I want to know what's cosecant and what's secant. Okay, so again, I'm going to put stars by those. Into the drop box for week 2, you are going to give me what fractions are cosecant and what fraction would be secant. So before you can give me those two, you have to find your x value first, right here. How do you find x? Since it's a 90-degree triangle, you have to use Pythagorean theorem to find your x. So find x first, then you can plug in your h divided by a and your h, or your h divided by o and your h divided by a. That will be how you get your points for the day. As we move through this semester, I will be sending you this chart through Kmail, so please don't feel like you need to copy it all down right now. You don't need to. I just am wanting to show you that as we move through Unit 1, we are going to come by more and more common values. We're going to really get used to seeing a lot of these. And I'm going to teach you, probably at our next session, how we find each and every one of these boxes. And after I show you how we find them, at that point you'll just be able to use the chart from that point forward. But it's important for me that you guys understand how did they get that number in the first place. And so we'll be setting all of those problems up. Probably, I believe it's next week. If not next week, then the week after. So that's it for now. That's all for week 1. I keep saying week 1. For week 2, so during this recording, I did ask you to solve and put a specific answer into the drop box to earn your points for this week. As a matter of fact, it was 2 fractions that you're supposed to put into the drop box. So if you missed them, go back, rewatch the recording, look for the ones that I pinpoint and say, these are the ones I want in the drop box, and you will turn your answers to those 2 fractions in to the drop box in pre-calculus for week 2. Just a couple quick reminders. In pre-calculus, your checkups are due probably every other day or every 3rd day. I put the answer keys for you to check your work inside Doc Sharing, so please be checking your own answers, and those assignments are credit, no credit. So it means if you've tried it and you've shown all your work, it's pretty likely you're going to get 100% on those assignments. Check your answers. If you have any questions on any of the checkup questions, maybe one doesn't make sense, send me a Kmail or give me a phone call and we can go over it. All right, thanks guys. Welcome to a new semester.